Alright, we're trying to build a light-seeking car. The finished circuit's supposed to turn on the motor when the car is around darkness and stop once it reaches a light source. So that's because of the photoresistor, which will increase light and increase resistance with light and slow down the car. And then when it gets to really bright, it'll just stop. The rest of the circuit's making that possible, turning on the motor with the lesser resistance of the photoresistor. So when it's dark.
Thanks, Patrick. Now the team is going to try to build the circuit. So, now it's time to build the circuit. Can we get it in the first try? Alright, the circuit is built. Now it's time to test the car. That's weird. Why doesn't it move? The car is supposed to move when there's a change in light. It's time to debug.
I'm telling you, the resistor's in the wrong place. It has to go to power.
You dumb, it literally connects to the other
Do you have to read the pre-lab? It says it resistor power and it goes back to the transistor.
Dude, it goes to the IC.
Dude, hey man,
You're
just go,
crazy.
You don't know,
Both of
dude.
you are
Go back
crazy.
to LAS, man. You don't know what you're talking about.
Yikes, that was hard to watch. But will debugging be successful? Will the car work now? The moment of truth. Oh, it doesn't work. Now what?
Guys, why don't we just work together? That would probably solve it.
Oh, that's a great idea.
Fine.
At this point, the team realized that insulting and blaming one another for mistakes was not going to get the job done. Let's see if this more collaborative approach is successful in creating a working car. By doing some research about each of the components in the circuit, the team as a whole has a better understanding of what needs to be changed. By working together, they find the bugs in the circuit and manage to come to a consensus without things blowing up, both figuratively and literally. And after the second debugging effort, it's time to test again.
Hi, this is June and this is my motor, so it's not moving with the light.
Sweet, it works. Thanks, June. So, what was the difference between these two debugging efforts? Let's rewind. There were two things that made the difference between an unsuccessful build and a successful one. The first is working together. Your team is there to provide multiple points of view on a problem, multiple pairs of eyes on a circuit when trying to find the problem, and multiple points of support for your own ideas. In the first try, none of this was there. We see lower team morale and time is spent blaming each other rather than finding a solution. In the second try, team members were able to ask opinions on an idea and get constructive feedback on whether it would work or not. Remember, more heads are better than one, especially in engineering. Second, a strategic approach to debugging is very important. Without knowing what to fix, we are essentially playing a dangerous game of trial and error. With the best case scenario, the car doesn't work, and the worst case, the breadboard starts smoking or someone burns themselves on a hot component. Instead, we can figure out what the problem is methodically, like by checking voltages across components and testing the circuit one section at a time. This way we are more likely to build a working circuit and less likely to injure somebody. It's great being an engineer, being able to build cool things like this and even cooler things down the road. As long as we remember to work together and approach everything with a strategy, the future of technology is in good hands.